6.2 Vector Addition. In this subtopic, we're going to learn how to add or subtract vectors. So when you add or subtract two or more vectors, you get a resultant vector, vector r, which represents the combined effort of the vectors. Now the resultant vector is just something like a displacement between the tail and the head of a vector. Now there are two ways that we can go about adding vectors. The first one is a head to tail method, where we add the tail of a method to the head of another method, where in this case we are adding the tail of vector v to the head of vector u, and thus what is the displacement? The displacement would be the vector from the tail of vector u to the head of vector v. The other method is the parallelogram method, or the tail-to-tail method, where we combine the tails of both vectors together. In this case, we are combining the tail of vector u and vector v together to form a parallelogram. But we are not there yet. We have to first move or translate both vectors for it to fulfill the head to tail method, so we can draw the diagonal. So let's start with vector v first. So vector v, we can add it to the head of vector u over here, and the same goes for vector u. We can add it to the head of vector v, and the resultant vector will be the diagonal of the parallelogram over here. Now, on to subtracting vectors. So when we say vector u minus subtracts vector v, we're actually saying vector u is adding the negative vector of vector v. So let's say our vector v is this. The negative vector is just the same vector but with the opposite direction. So, and we have vector u here. So when we are adding vector u to vector negative v, we are also using the tail-to-tail method to create a parallelogram. So we can just do what we did before by translating the vectors around as so, and finding the diagonals to find the resultant vector. Next, now one thing you have to know is that the ground speed is the sum of the airspeed and the wind velocity. So imagine you are an airplane in the sky with a certain airspeed, and there is wind blowing around you. If the wind is blowing exactly the same direction as you are, it is actually pushing you forward, right? Yeah, which will increase your overall ground speed. However, if the wind is pushing against you, the wind is actually slowing you down, thus decreasing your ground speed, because the wind is acting like a force acting against you. That's why you are moving slower. Now let us do a word problem here to visualize a bit what that meant. So an airplane is traveling at a velocity of 450 kilometers per hour south 20 degrees east when it encounters a wind with a velocity of 140 kilometers per hour north 40 degrees east. What is the ground velocity of the airplane? Now remember, when they ask ground velocity, we must include the magnitude and the direction. Now the first step to solving this kind of word problem is to always sketch out the problem. So I have a compass here. Let me just label it north, south, east, west. So the first thing that we have to draw now is the airspeed vector. Yeah, so we can draw the vector using the information given, which is south 20 degrees east. So it should be somewhere here with 20 degrees between them and a magnitude of 450. Now the next thing we have to draw is the wind vector given by the information here. So again, we can just draw another compass right here. And just draw and just continue this vector. This is a vector and just continue it. So north, if this is north, this is east. So north 40 degrees east would be somewhere here. So this angle is 40. So as we can see, using the head to tail method of adding vectors, we get that the resultant vector is this one here. So now we have to find the magnitude of this, the ground speed. N140. Now, before doing that, we must find this angle. Now, if you notice, this line and this line are actually parallel lines. So that means if this is a 20 degrees, this will also be 20 degrees too. So now we can draw another triangle with all the given information that we have just found. So this is 40, 450, 140, 40 plus 20 is 60, and this is what we want to find, the ground speed. So by using the cosine law, we can find the ground speed. So let me just quickly write out the formula. And if you do the calculations, you will get the magnitude of the ground speed to be roughly approximately 398.9 kilometers per hour. Okay, so now we have found the magnitude, we still need the direction. So the direction is actually, we need to find the direction of this line, So the direction would go from here to here. So we already know this is 20. Now we just need to find this angle. Let us label it as theta. So since we have the length of magnitude of this line, we can use the sine law to find theta. So let us say sine theta over 140 equals sine 60 over the value that we found, 398.9. So if you complete this calculation correctly, you will get theta to be 17.7 degrees. So now you can write a concluding statement, which is 398.9 kilometers per hour in direction of south, 17.7 plus the previously 20, 37.7 degrees east. Next, now given a cube, we have to write each vectors in terms of vectors A, B, and C. So vector BC is just the opposite of vector A, because vector A is parallel to this, parallel to this, parallel to this. So we can just write negative vector A. Vector GF. Yeah, as I said previously, if A is parallel to this, then vector GF is also vector A. Now OB. Now OB is actually this diagonal. But how do we find it? Well, we can just add vector A to vector B, since vector B is the same as here. So we can just write vector A plus vector B. Again, AC. Oh, but now we have to go backwards in order to to go backwards here first and then only here. So when we go backwards, of course it's negative vector A plus vector B. BG, vector BG. So from here to here. So again, same, we have to add probably two vectors together. Well, we can go up first and go backwards on vector A. So it is negative vector A plus vector C. Or we can always write vector C first minus vector A. OF. So OF, first we'll have to go up first. So we'll use vector C. Then we'll go straight and we'll use vector B, and we'll go right and we'll use vector A. So basically this is a combination of all three vectors, vector A, vector B plus vector C. And that's it for 6.2. Thank you.